Done. Now we need to input this data section, or you can see our well here depicted here. Now we double click here and we will select the current pump. First, actually, we can click cancel, and to check the database, design, click database. All right. So we have options, gas lift, the catalog for the ESP, HSP, progressive cavity pump, jet pump, suckrod pump, and of course, multiphase pump. We have one subsea H series, HX series, and Sulzer, right? But blank here. Okay, so we can click cancel and go back to this data input. In this case, for the current pump, I will select one subsea H800 /65 pump configuration single pump with power available 350, but later on we will perform sensitivity. Pump wear factor 0. All right. And for the frame size, automatically populated with this value. All right. Maximize. Okay, so from here, you can check this one. A specification of all one subsea multiphase pump hydraulics can be found in the design database option on the main menu. As I showed you before, the add option makes it possible to specify a user-defined multiphase pump, right? If you select this add option, and the multiphase pump hydraulic name reflects the nominal flow rate and maximum differential pressure. Okay, so the name H800 /65 reflects the nominal flow rate and maximum differential pressure. I will show you later on. Okay, so from here, we can click done. All right. Okay, we can check it again. Usually we have the plot here, the pump differential pressure against the pump intake total flow rate. And maybe later on we can have the plot here. All right. What about curve details? Let's see. Select. Okay. Nothing. Select curve. Done. Not yet. Okay. I think something needs to be done, but I think we can leave it as it is. All right. Click done. So from here, we can go to the calculation to perform the nodal analysis. All right. And for the top node pressure, in this case, the manifold pressure, 500 with water cut, of course, 80%, total GOR of 800 as per previous data input in IPR section. And then for the vertical lift correlation, we can use this one, rate method. I prefer geometric so that we can capture the unstable zone of the nodal analysis, right? And for the left hand intersection, disallow. And lastly, you can select no. And we will perform sensitivity analysis. We click cases, open the drop-down menu, the first drop-down, go to find this one, power available. I will vary the power, all right? And we will input starting from 250, 300, 350, 400, 450, 500, 550, and lastly 600. Click done. All right. We can click done first. I want to check the data section. Double click. Error rising. I don't know what happened. Double click. All right. What happened? We need to make sure. Let's press calculate. It's okay, actually. No problem here. All right. Okay, please be careful here. We have this plot, pump discharge pressure versus VLP pressure plot. Okay. So first we are in this one, 250. You can see the intersection by maximizing this section. All right. The intersection between this PDP curve and VLP curve. All right. And you can see the intersection shows the operating point. So now we have liquid rate from our well of 8,647 stock tank barrel per day. So this is our flow rate using this multi-phase pump at this power available. We can go to the next case, maximize, and we obtain higher flow rate, 8,981. Again, maximize 9,300. Increase the power, we get higher flow rate, and so on and so forth. All right. And from here, we can select this one, sensitivity plot. Now we have pressure against the power available. All right. You can see as we increase the power available, we will increase the flow rate, and of course, the pressure will decrease. All right. And check the variables. Let's see the liquid rate. It should increase as we increase the power available. All right, so if you increase the power to the pump, to the multi-phase pump, you will achieve higher flow rate, higher liquid flow rate. And of course, assuming the constant water cut, we can also have increased oil rate, all right, with the same water cut. So this pressure should be, let's see, this should be bottom hole flowing pressure because the value is around 3,000. So it cannot be wellhead pressure, it should be bottom hole pressure. All right, so by increasing the power available, you increase the flow rate, and of course, the bottom hole flowing pressure will decrease. You can also plot the other variables. All right, but we can show the oil flow rate. And from here, we can check the other plot, system plot, plot all cases. I want to show you the IPR and the pump discharge pressure. Done. All right, so this is the system sensitivity analysis. We have the IPR and the PDP, the pump discharge pressure. All right. You can uncheck. Okay, so these curves are actually the pump discharge pressure, whereas this one is the IPR. All right. All right, and we can click finish. All right, so please be careful here. We are playing with the difference of scale here. If I uncheck here, you can see this is the IPR. All right, you check the pressure starting from 0 to 4,800. But if we are playing with the VLP, I mean the pressure, pump discharge pressure, we're actually starting from 50,000, all right, down to 0. And of course, the scale is different. So that's why if we plot them together, we will have something like this. All right, so again, you can check the intersection. All right, so this is the IPR and PDP. All right, but actually for this case, we should not see or we should not observe the intersection between IPR and PDP, because as you can see, the intersect gives us liquid rate of around 400, whereas in the previous picture, the previous results I showed you that the flow rate, the production rate should be around 8,000 stock tank barrel per day. All right, so we should not see the intersection between IPR and VLP that will give us the final production rate, right? Because as you can see, we are now playing on the surface, not on the bottom hole. All right, in the conventional nodal analysis, we usually do the IPR and VLP, both of them analyze in bottom hole level, whereas here we have multiphase at the surface. All right, so we should not see the intersection as the operating point, the intersection between IPR and the PDP. All right, the proper identification, actually, we can click finish by looking at this one, the VLP and the PDP.